Hello everyone. So in this video, we're going to be doing another recursive example. So basically I have here Sublime text and I'm using the terminal here, running the bash command. It's already loaded in here. Yep, here we go. So recursion underscore p5 is the name of the file. So but yeah, basically, so let's get started. The goal for this one is you have an array uh, just from 1 to 10. So let's define that. X equals, um, actually you could do 1 to 10. We save this. Actually, if we do a range, call it range 10. Yeah, that will work. But we'll go ahead, that's one way. We'll just comment that out. The other way is you can just do the array here. 5, 6, 7, 8, 9, 10. So the goal for this one is basically um, have the array printed out as it is, and then move the index by 1. So it's like 1 through 10, then 2 through 10, then 3 to 10, all the way down to 10, which is the only value. And then you'll be done with the I guess the problem. Very simple to do with the nested for loop, but it's a little bit more tricky to do recursively since, I guess at the end I will kind of explain what are kind of the similarities when you come up with a recursive solution to a problem. What are kind of the similarities with that and like a nested for loop or any for loop based kind of algorithm? So let's get started. So first we're going to do is we're going to define our function, call it get values, and we'll call it D, a data structure. And then we're going to define our helper function. This is very important, knowing when to call helper functions. And this is required because we're going to be traversing to the array. And also it's like two-dimensional traversal. So we're going to need 2 more variables. We're going to need the array itself, the index, and then p, which will be like going, like you print out like in one pass, and then p would go increment, and then you're going to do a second pass with the starting index being at 1. So it'd be at 2 through 10. So 1 through 10, and then 2 through 10. So it's very important to know how many variables you need. And it's also kind of good to kind of keep your variable count down, since kind of want to keep it concise. If it's not needed, if it is needed, definitely then you need to consider including it. So let's define our helper function. So actually we need to give it a different name. Values box. And then we can just do D, I, and P. And actually to start off, we're going to start on the 0 index, and it's going to be our first pass, which is index 0. So 0 based, our first pass through the array. So let's get started. So let's define what we want. So we want to do our base case. Our base case is going to be if our index equals the length of D, which means our path is complete. We want to print just an empty statement to get on to the next line. And then in the case that our the path that we're on is also equal to length of D, because we're going to do 10 passes for this example, right? If it does equal to 10, then we want to return. And then else, we want to get values aux, and then call D, and then we want to increment our path. Interestingly, our path is going to be our starting index. So path zero, pass 0, we're going to start at index 0. Pass 1, we're going to start at index 1, and then pass 2, we're going to start at index 2. So that's hence the p plus 1 as the parameters. So in the case that we haven't reached the end of our line, particular line, we want to just continue on moving. We want to print the value, first print it on the same line. That's important. So end equals, and then just put a space in. Here, put a space. And then we want to recurse here as well. Okay. D I plus 1 P. Okay. That is kind of how do we define it. So let's give it a go. So we can do print, print x, save it, and then load in our cursor. Oh, here, we're actually missing a colon here. We'll save it here. Oh, let's see, it just printed. Oh, we just printed x actually. There's x. We want to call get values aux. X. We can comment this one out. So we're missing a few values here. Get values aux, missing 2 required positional, line 19. Oh yeah, so we don't need to call the aux. We just need to call get values, which will then call the aux helper function. So there we go. There we got our what we needed, what our end goal was. We can also do, actually we could try this. Y equals x 1 0 through 5. Let's see if this would work. I'm not sure if the syntax is correct though. There we go. Yeah, so we just took a partial of the x array. And yeah, so now we have this recursive method. So if we kind of look at a for loop, so if you have a nested for loop, you have index I and j like normally. So you'd have your index, you'd have your outer index, which would be your p, how many paths, right? And then outer for loop, and then your inner for loop would be doing the lines, which is your I here. So in the for loop, you have incrementing, you increment either the paths or within the line. So the incrementing is actually being done here. So this is the inner for, this is basically the inner for loop, right? And then this is basically going on, this is what's being done in the outer for loop. So yeah, so we can just say this is outer for loop, recursion, and then inner for loop. Yeah, so that's kind of the similarities. The recursion is very very intricate, very elegant way of programming. Definitely, I would say to take a look. You know, you have to see that which like it's kind of difficult to kind of see how things get mapped. You know, ultimately they're doing the same thing. You're going to get the same values out, but it can be a little bit tricky to when to recurse is very important. So yeah, hope you enjoyed this video. Any comments and suggestions would be really helpful. Thank you, and see you in the next video. Bye.